So I'm going to wait for a few people to get in here before we start, but hopefully we'll be able to fix this board today. Shouldn't be that hard of a board to solve. So I'm going to wait for a minute. Okay, so today I'm going to be going over a 820-3115 that does not turn on. So what's I should say, it does not turn on the charger. So our first URL that we need to check, let's set our multimeter since my tech power, the battery went dead and I still have not put a new battery in. So let's plug it in and let's see what we get. So plug it in, we get a green light in the charger and quarter fan spin, of course. So let's measure what PP bus G3 hot is. So one lead on ground, one lead on the fuse, and it is 14 volts, which is too high. So 14 to 3. So why would PP bus G3 hot be cycling to 2 volts? 2 volts to 14 volts. Why? What would cause that to happen? So let's go over, I know I guess we can't go to the schematic, but because it's on a different computer, but if the computer does not know how much current it is using, how will it know what to output? It won't. So without current sense, nothing is going to work. So we are going to set our multimeter to resistance mode. We're going to check pins 17 and 18 and 28 and 27 of the ISL 6259 chip. So let's do that. So pins 27, 28 are 20 ohms. That is perfect. So pins 17 and 18, make sure I can plug this. Open line on pins 17 and 18. Now, what would cause this? You'd think a blown current sense resistor may cause this, right? If the line is showing open, maybe there's a blown current sense resistor. Is that a possibility? Maybe. So let's check these resistors. So I don't, they're about 1 ohm, I think. I don't know. I really don't know. I'm just measuring. We'll see if it's a strange value. So one resistor is 2 ohms, and the other resistor is 1 ohm. So that is not going to cause it to be open line. Now, where does this go? Where do these current sense resistors go? So if you could see the screen, which you probably can't, let me see. Let me change this color scheme to dark real quick. Dark. There, now you'll be able to see a little bit, I should say. Okay, so you're going to see our R7051 is charger CSO RP. This is going to go over to the shunt resistor right here. So what do you think? Should we check continuity to that shunt resistor? Because both these circuits are completed at this shunt resistor right here. So if there is no connection between this shunt resistor and these current sense resistors, it will not work, and therefore you'll have open line on pins 17 and 18. So let's check in diode mode and see if we have continuity there. So back to diode mode. Let's measure on one of these resistors here to the shunt resistor. We have open line again. So let's measure on the other resistor and the other part of the shunt resistor. Open line again. So how could we fix this? How could this be solved? Very simply. Now you think, well, why is that blown? There's probably a trace that burned somewhere in the substrate of the board. Now, why that is, good question. Let's check resistance to ground, because if there's a short to ground, it could have burned out that trace. So let's check short for short. So we're going to check on both sides. We have no short there. That's a very healthy voltage drop to ground. No short here. What am I breaking today? Well, today I'm going to be breaking a 820-3115. We do have a short. No, we don't. We do not have a short. So, fairly healthy voltage drop to ground. So, theoretically, all I need to do is take two wires and run them from both of those current sense resistors to this shunt resistor, and this fan will spin normally. So, let's do it. Get our jumper wire, and we will run a couple of wires, and hopefully this is going to fix it. If not, this board will go in the pile for another day. Because I really want an easy one today. Oh yeah, and the fume extractor is not working either. And my heating element, my iron is dying. So here's one wire. We're going to just loop it around to right over here to this shunt resistor. I'm going to tin this, let it solder. See, my heating element's dying, so I need to get an FX951 finally. So I don't want this wire to get in the way of where I'm soldering, because I do not want to burn the coating off and have it short across the board, even though these lines aren't going to do anything. Actually, it probably is 12 volts, I don't know. I don't know what half of this stuff is. All I know how to do is make it work after it's not working. So, bad power strip that I don't feel like diagnosing right now. Power strip's easy to fix. Come on, little wire. There we go. A good joint. How both these traces got messed up, I have no idea. I think the ISL went bad or something and cooked them. I changed the ISL also. Cannot leave. It's a surge suppressor, exactly. It's cheap. I'm not even going to waste my time on it. But sometimes I like to fix things. Well, it's kind of my job to fix things. So, second wire, and hopefully this fan will spin. And not quarter fan spin, because quarter fan spin is no fun. I cannot stand quarter fan spin. Quarter fan spin that I could find the issue with is easy. I like those kind of jobs. But quarter fan spin that everything is fine with quarter fan on boards that everything is fine and you cannot locate what is causing it. Those are the boards that I can't stand. Oh, come on, what'd I do? Did I seriously break that wire? Oh, I broke the wire. Come on, really? How did I break that wire? No idea. Yeah, Chuck, I was gonna get a new scope, but then I used one and I fixed it and I said nope. I didn't like it at all. I'm getting a new iron to order it probably today. Okay, this wire's got to go. Somehow I broke it. I don't know how. It must not have been. It like broke halfway, so probably the piece of the wire was broken. That sucks, so we will replace the wire with a better wire. Off of the board. Okay. So let's finish this other one first. And then we should theoretically have 3 ohms on this line because somehow, someway the trace got messed up. And I have no idea how or what would do that. Because this board is perfectly clean. So who knows? That just goes on to the board repair mysteries of my desk. No, I used the other AmScope and I did not like it. The working distance was lousy on it. The field of view was lousy and the eyepieces were really uncomfortable. And the field of view on this is so wide that it's incredible. And on the other ones, it's not very wide. Yeah, and quarter fan spin is evil. Basically what happens is it reaches an SO state, then reverts to S5, and what can cause that is endless. Anything on the board can cause that. A bad ISL can cause that. A dead CPU can cause that. Dead PCH can cause that. You name it and it could cause quarter fan spin. Little random resistor somewhere knocked off can cause it. It's not my favorite issue. My favorite issue is like these. Current sense O.L to the shunt resistor. Now the good question is, why did that end up like that? Who knows? I don't know and I don't care. I just want this fan to spin again. Yeah, you can, but my scope does the job. It's not limiting me in any way, shape, or form. Now my iron, on the other hand, heating element's dying. And the thermal recovery on it is just going downhill worse every day. And I don't like my other wire because the position is probably going to break. Yeah, the iron though, I need a new iron. It's like it's starting to get stuck on big pads, and even turned up all the way it still stays stuck, so that's no good. So I'm going to go back and revise one of my wires, but first we're going to test. This could go on fire, so. Come on. So, now that my eyes and throat are burning, not having a fume extractor, let's test in resistance mode what continuity on the ISL is. No, I'm not going to buy one off eBay. I'm going to buy it new. But so is 3 ohms. So this should work. So when I plug in the power, it's either going to do two things. It's going to work. It's going to go on fire. So let's plug the charger in. And now we have no green light on the charger. That is a spinning fan.